Hello everyone, very good evening. Very good evening everyone. Kindly confirm if audio video is clear. Good evening everyone. Please confirm if audio video is clear. Yeah, sure. All good. Okay everyone, let's start the session. So, this is the ninth lecture of set theory and algebra. In the last class, that is yesterday, we discussed the concept of introduction function. So we introduced the concept of function. We have understood that what do we mean by domain of a function, what do we mean by codomain of a function, and what is the range of the function. So domain of the function for which the function f is defined, codomain, that means the set from which the function can take its value, range is the actual values taken by the function. Clear? So domain, codomain, and range of the function. Then we try to define the number of functions from set A to set B. So number of functions from A equals to n raised to the power m. What is this? Where mod A, that is the number of elements in the domain, are m, and mod B, that is the number of elements codomain, are n. So basically, the number of functions from set A to set B will be nothing. Size of the codomain raised to the power size of domain. Size of the codomain raised to the power size of domain. Then we introduce the different types of functions: identical function, identity function, then what else? Yeah, identical function, identity function, and constant function, and composite of two functions. So that's what we have discussed in the last class. Sir, what are we going to discuss in the today's session? So the most important thing from which the question can be asked from the topic function are the concept of one function, which are also known as injective function, concept of onto function, also known as surjective function, bijective functions. So basically, bijective functions are nothing but one as well as onto. So the functions which are injective as well as surjective are known as bijective. So that's what we will discuss. And then we will try to understand that how do we calculate the inverse of a given function. So given a function, if somebody asks you that what will be the inverse function for that function, so that's what we need to calculate. Apart from that, we also need to understand that what are the scenarios in which the inverse of a function can exist. Is it possible that inverse of a function, inverse of every function will exist? No, sir. Inverse of a function can exist only in certain scenarios, and that's what we are going to discuss. So that's here only that inverse of a function will exist only if the function is bijective. So let's begin the session. So first of all, injective function or one function. So what do we mean by injective function? Hi sir, क्या possible है गेट निकाल? अरे MN 10 months are more than sufficient, Baba. More than sufficient. I mean, I don't want to tell you, but I cleared my GATE examination only in the preparation of 2.5 months. So I'm not saying that, I mean, it's a different thing. But anyway, 10 months will be more than sufficient. You have 4 times the time that I had. Okay, so don't worry about that. Yashu, very good evening, Yashu. Okay, so let's start with the injective function. So what do we mean by injective function? Let's assume, first of all, we are trying to define the definition of injective function. So what do we mean by injective function? If we have different elements in the domain, then the different elements in the domain should have different images in the codomain. Okay, so what does it mean? So let me explain the concept that this is your set A, this is a set B. First of all, anyway, it should be a function. But if I give you a scenario and I ask you whether it is a one function or not, tell me, this is a one function or not? No, sir, it is not a one function. Why exactly it is not a one function? Sir, A is not equals to B. We know that A is not equals to C. A is not equals to C. A and C are two different elements, but their image is same. A is not equals to C, but f of A equals to f of C. That is, images are same, therefore not 1, 1. It is not a 1, 1 function. Okay. What else? Sir, I give you the definition, don't worry. I'm just giving you the example, then I'll give you the definition. Now, let's assume that this is your set A. I have element A. This is your set B. Element 1, 2, 5. Now, if I ask you that this is a 1, 1 function or not, so do you realize that all distinct elements of domain are having distinct images? Distinct elements of the domain are having distinct images in codomain, therefore 1, 1 function. So what do we say? Distinct elements of domain are having, or rather I would say all distinct elements of domain are having distinct images, therefore 1, 1 function. So that's the definition of a 1, 1 function. What is the definition of 1, 1 function? Let's go to the next slide and you will understand it. So a function f from A to B, so this is from A to B. A function f from A to B is said to be 1, 1, is said to be 1, 1 if and only if distinct elements of A have distinct images in B. So no two distinct element of set A should have same image in set B. If this condition is satisfied, then the given function will be called 1, 1 function. Now let's try to understand another thing, that is it possible that for any cardinality of set A and set B, for any set of size A, for any set A and any set B, the 1, 1 function from set A to set B will exist? No, sir, it is not necessary. Now let's try to understand. Let's try to understand. If I have 4 elements in set A, B, C, D, and if I have only 3 elements in set B, is it ever possible to have a 1, 1 function from A to B? Let's try to construct a 1, 1 function. A has image 2, let's assume B have image C, C has image 3. Now the idea is, if element D of domain does not have any image in the codomain, then it will not be a function. But if any one of these 3 elements become the image of element D, then it will not remain a 1, 1 function. So the idea is, sir, if the cardinality of set A is more than the cardinality of set B, if the cardinality of set A is more than the cardinality of set B, then we can never have a 1, 1 function from set A to set B. So what is the condition for the existence of a 1, 1 function from set A to set B? Now let's assume that if cardinality of set A is smaller than the cardinality of set B, then can we have a 1, 1 function? Let's assume 3 elements, there we have 4 elements. So can we have a 1, 1 function? Yes, sir. It is a function. Yes, sir. It is a function. We may have some elements in the codomain which are not mapped by any element. It is not necessary for every element of codomain to be mapped by at least one element of the domain for a function to be 1, 1 function. Right? So this is a 1, 1 function. Now what if the cardinality of set A is equals to cardinality of set B? That's it. Let's assume that both these sets have equal number of elements. Okay. 1, 3. Can we have a 1, 1 function? Yes, sir. This set is a 1, 1 because distinct elements of the domain are having distinct images in this case. Also, distinct element of the domain may have distinct images in set B. But if the number of elements in set A are more than the number of elements in set B, then it is never possible to have a 1-1 function from set A to set B. So what is the condition? What is the condition? Let A and B are finite sets, then a 1-1 function is possible from set A to set B only if when exactly it will be possible, only if cardinality of set A is more than, sorry, cardinality of set A is less than or equal to the cardinality of set B. Here, cardinality of set A is less than or equal to cardinality of set B. So you can actually see that if cardinality of set A is less than cardinality of set B, then also a 1-1 function is possible. If they are equal, then also a 1-1 function is possible. Now let's talk about number of 1-1 functions. So we know that total number of functions from set A to set B will be cardinality of set B raised power cardinality of set A. But how many 1-1 functions will be there? Among all those n raised power m functions, how many of them will be 1-1 function? That's what we are trying to understand. So number of 1-1 functions. Number of 1-1 functions. So let cardinality of set A is m and cardinality of set B is n, such that obviously it is necessary, because if m is not less than or equals to n, then we can never have a 1-1 function from set A to set B, such that m is less than or equals to n. Then number of 1-1 functions possible from A to B will be what? So total number of functions possible will be how many? Total number of functions possible are obviously n raised power m. We have already discussed in the last class. Now, let's assume that we have a set A which contains m number of elements, that is 1, A2, A3, m. Let's have a set B which the number of elements are n. Call it B1, B2, n. How many functions are possible? Sir, the first element, that is A1, can map with any one of these n elements. Therefore, for the first element A1, we have n choices. Such that, because the element A1 can actually map with any one of those n elements, therefore, first element will have n choices. Sir, now if your element A1 relates or is mapped with element B1, then my question is it possible for A2 to relate with this B1 or A2 to map with this element B1? No, sir, it will not be possible, because A1 and A2 are two distinct elements. They cannot have same image in the codomain. They cannot have same image in the codomain. So the possibility is that if A1 has already mapped with one of those n elements, then for A2, we will have only n minus 1 choices, because the element A2 cannot map with the element with which element A1 has already mapped. So, for element A2, we will have n minus 1 choices. So, how many elements are gone? Sir, out of n elements, 2 elements are gone. One is mapped by A1, another is mapped by A2. So, for A3, we will have only n minus 2 choices. For A3, we'll have only n minus 2 choices. Now, sir, how many choices will be there for the last element? Sir, there are m elements in set A. We have already mapped m minus 1 element of codomain. We have already mapped m minus 1 element of codomain. So, out of n, we have already mapped m minus 1. So, out of n, we have already mapped m minus 1 elements with the remaining m minus 1 elements of domain. So, for last element, you will have m minus 1 choices. You will have m minus 1 choices. So, how many functions are possible from A to B? So, the number of functions will be, for first element, you will have n choices, and for second element, you will have n minus 1 choices, and for third element, you will have n minus 2 choices, and sir, for mth element, you will have n minus m minus 1 choices. Yeah. So, Either you can use this concept. So these are the number of functions from set A to set B. I can simplify this. So please try to understand. Let's go to the next slide. So n into n minus 1, n minus 2 up to n minus m. Please look at this. N minus m minus 1. Okay, sir. Now, sir, if I multiply and divide this number by the same number, that is, sir, n minus 0, n minus 1, n minus 2, n minus 3 up to n minus m minus 1. So now what will we do? Sir, now we'll say n minus m, because this will be n minus m minus 1. So basically, if you look at this, it is nothing but n minus m plus 1. Nothing but n minus m plus 1. So this is n minus 0, n 1, n minus 2 up to n minus m plus 1. So now n minus m into n minus m minus 1. So keep subtracting this. You in the end you will be left with 3, 2, 1 elements. Same in the denominator, n minus m, n minus m minus 1, 3, 1. So sir, if you look at this, what is this? In the numerator, it is n into n minus 1, n minus 2 up to 3 to 1 is n factorial divided by n minus n minus m minus 1, n minus m minus 2 up to 3 to 1 is nothing but n minus m factorial. Sir, what is this? Do you remember one thing from your 11th class mathematics? NPM is nothing but n factorial upon n minus m factorial. Or if you, yeah, generally you will remember it in the form of NPR. So NPR is n factorial upon n minus r factorial. N factorial upon n minus r factorial. So if we replace r by m, so n factorial upon n minus m factorial will be nothing but npm. Nothing but npm. So whatever is written here, n into n minus 1 into n minus 2 up to n minus m minus 1 is nothing but npm. So it is permutation of n elements taken m at a time. Permutation of n elements taken m at a time will give you the number of 1-1 functions from set A to set B, where n is the cardinality of codomain and m is the cardinality of domain. Clear? I hope it's simple. Now, if I ask you, okay, let's analyze this. What? Note. If mod A equals to mod B equals to n, if these cardinalities of both these sets are same, if mod A equals to mod B equals to n, then number of 1-1 functions possible from A to B will be equals to npn. So what is npn? It is n factorial divided by n minus n factorial. So it is nothing but n factorial divided by 0 factorial, which is n factorial. So anyway, much directly n factorial. So if the cardinality of set A is equals to cardinality of set B, then the number of 1-1 functions possible will be n factorial. Now please try to understand. Please try to understand that. Let's think that's for A1, if both of them are n, then for A1 we will have n choices, for A2 we will have n minus 1 choices, for A3 we will have n minus 2 choices. For the last element there will be only one choice, so it will go up to 3 to 1. So for n elements there will be if cardinality of both these sets are n, then the number of 1-1 functions will be n factorial. Okay, I hope that you all have understood one thing, but please try to understand. Yeah, anyway, I'll come back to this particular slide in a while. I'll come back to this particular slide in a while to understand, to explain one concept, that what happens if mod A equals to mod B. What happens if mod A equals to So I'll get back to that. But before that, let us understand the concept of onto function, because this expression is related to onto function. Let's understand the surjective function or onto function. So when do I say that a function is onto function or surjective function? So the idea is, for a function to be surjective, it is necessary that every element of the codomain must be mapped by at least one element of the domain. So if I say that this is your set A, this is your set B, so the idea is I'm not writing the definitions as of now, but please understand. So if I have 1, 2, 3, 4, that's 1, 2, 3. Now please tell me if A is related to 1, B is related to 1, C is also related to 2. Now the idea is, this element 3 is not mapped by any element of domain. So the definition of onto function says that every element of the domain should be mapped by at least one element of the codomain. Now, therefore, not an onto, not an onto function. Now, please with this. So, what if is the scenario? Every element of the codomain is mapped by at least one element of the domain. So, at least or more than one is not a problem. Try to understand. Next, A. This is your set A, B, set B, 1, 2. Now, if the mapping is like that, A is related to A relates with also B relates with. Is it a function? Yes, sir. Every element of domain maps with exactly one element. Therefore, it is a function. Every element of codomain is mapped by at least one element of the domain. Therefore, both are onto function. Both are onto function from A. So when do we say a function is an onto function, sir? If there is any element in the codomain which is not mapped by any element of the domain, then it will not be an onto function. But if every element of the codomain is mapped by at least one element, one, exactly one, or more than one, not a problem. So it should be mapped by at least one element of the codomain. So that's the definition of surjective or onto function. What does it say? Sir, a function from set A to set B is called an onto function if each element of set B, that is codomain, if each element of set B is mapped by at least one element of set A, that is domain. So each element of codomain must be mapped by at least one element of the domain for the function to be called onto function. So sir, this is not an onto function. These two are onto function because every element of codomain is mapped by at least one element of the domain. Now please try to understand. In this particular case, range of the function will include only 1 and 2, whereas codomain will include 1, 2, 3. So in this case, range is not equals to codomain. In this particular function, range is not equals to codomain, but in these two functions, range is exactly same as codomain of the function. All the elements of the codomain are mapped by at least one element. Therefore, range equals to domain. Sorry, range equals to codomain. Here also, range equals to codomain. So, what is the simple condition for a function to be called onto? So, surjective onto function. Codomain map at least one. Yeah. So, that is in an onto function. In an onto function, range of the function must be equal to the codomain of that function. Range of the function must be equal to the codomain of the function. Now my question is it possible that in whatever the size of set A and set B, every function will be onto? No sir, we have already seen that this function is not onto. But when exactly it is possible that a function from set A to set B is onto. Now, please, sir, if mod A equals to mod B, then a function may be onto. If the cardinality of set B is less than the cardinality of set A, then also an onto function is possible from set A to set B. But my question is, what happens if the cardinality of set A is, let mod A is greater than, sorry, mod A on, what are you doing? Mod A is less than mod B. Oops. Sorry, mod A is less than mod B. Got confused? Okay. Let's assume that A, B, B. Now, the elements in set B are 1. Can we have an onto function? Yes, sir. Definitely we can have an onto function. More than one elements are possible. Sir, even if equal, then also. Sorry for repetition. So, if cardinality of set A equals to cardinality of set B, then onto function is possible. If cardinality of set A is more than the cardinality of set B, cardinality of set A is more than the cardinality of set B, then also onto function is possible. So, onto function from A to B possible if mod A is either greater than or equals to mod B. But what if cardinality of set A is less than cardinality of set B? A has 3 elements, B has 4 elements, 1, 2. Now my question is, sir, it's okay that let's try to map maximum of the codomain. Done. Now my question is there any element in the domain which can relate with this element 4? No, sir. Now the idea is, if I try to map any one of the existing element with, if I try to map this element 4 with any one of this existing element, then it will not remain a function. Then it will not remain a function. So, onto function not possible. Function not possible. Okay, so an onto function from set A to set B is possible only if cardinality of set A is either equals to cardinality of set B or greater than the cardinality of set B. So only if mod A is greater than or equals to mod B. Clear? Now let's go back to the example. Now please try to understand. Please try to understand. What did I say? If mod A equals to mod B, if mod A equals to mod B, then number of 1 functions possible from A to B will be n factorial. But my question is, if mod A equals to mod B, then try to construct any 1 function. Let's assume A relates with 3, fine. B relates with 1, fine. Now C cannot relate with 1 and 3. Therefore, let's assume that C relates with 4 and D relates with 2. So do you realize if mod A equals to mod B, then every 1 function is guaranteed to be onto. If mod A equals to mod B, then every 1 function is guaranteed to be onto. So we can simply write down the treatment. What? Number of 1 function. Down. If mod A equals to mod B, if mod A equals to mod B, then every one function from set A to set B is onto, and every onto function from set A to set B is 1 1. So what can we say? So that means if mod A equals to mod B, then number of number of onto functions will be exactly same as number of onto functions. Note. Because every 1 function is onto and every onto function is 1 1. Therefore, number of 1 function will be exactly same as number of onto function. Number of onto function will be exactly same as number of 1 function. Yeah. So note, if mod A equals to mod B, then number of 1 functions from A to B will be equals to number of onto functions from A to B. And if I say that the value of mod A and mod B equals to n, then how many 1 functions are possible from set A to set B? If mod A equals to mod B equals to n, then number of 1 functions possible from set A to set B will be n factorial, and all of them will be onto functions as well. So if mod A equals to mod B equals to n, then number of onto functions possible from A to B will be n factorial. Please try to understand a simple concept that in case of 1 function, it is easy to obtain the number of 1 functions possible from set A to set B. In case of 1 functions, it is easy to obtain the number of 1 functions possible from set A to set B, and we have already calculated that if mod A equals to mod B, if mod A equals to, if mod A and mod B are the size of domain and codomain, then the number of 1 functions possible will be size of codomain permutation with size of domain npm. But in case of onto functions, it will be tricky. So please try to understand. There will be 3 different cases, or more precisely 4 different cases. So this is your case 1. This is your case 1. So when mod A equals to mod B equals to n, then number of onto functions possible from set A to set B will be factorial. Now let's talk about case 2. Case 2. If cardinality of set A is any value n, and cardinality of set B is exactly 2. If cardinality of set A is n and cardinality of set B is 2, such that n is greater than or equals to 2, because if n is not greater than or equals to 2, then onto function will not be possible. Then onto function will not be possible. If mod A equals to n and mod B equals to 2, such that n is greater than or equals to 2, then number of onto functions possible from A, B will be equals to what? Any answer? How many onto functions will be possible in this case? How many onto functions possible in this case? Number of, please tell me the answer. I'm writing the same thing but differently. Number of onto functions possible from, not two, sorry. Please try to understand this concept. Why this becomes so tricky to understand that. But let's assume that there are n elements in set A. One, and in set B there are only two elements. One. Now please try to understand, if all these elements of set A maps with element B1 of set B, then not onto. And similarly, if all the elements of set A maps with element B2 of set B, then also the function is not onto. Clear? Not onto. In this case, it is not onto because B2 is not mapped by any element of the domain. This is not onto because B1 is not mapped by any element of the domain. Now my question is, can I have any other function? Can I have any other function from set A to set B which is not onto? Can I have any other function from set A to set B which is not onto apart from these two functions? Apart from these two functions, one is when every element of set A maps with element B1 of set B, another when every element of set A maps with element B2 of set B. If you have any other function, then the elements of set A will include both the elements of codomain. That means no element in the codomain will be present which is not mapped by any element of the domain, and it will become an onto function. So the simple idea is, sir, how do we calculate the number of onto functions possible from set A to set B? Sir, number of onto functions possible from set A to set B will be total number of functions possible, total number of functions possible from A to B, minus the number of functions from A to B which are not onto. So total number of functions possible from set A to set B will be 2 raised power n. Yes or no? Cardinality of codomain raised to the power cardinality of domain. Total number of functions possible will be 2 raised power n, minus there are exactly two functions from set A to set B which are not onto. Therefore, subtract those functions which are not onto and you will be left with number of functions which are onto from set A to set B. So, the final answer for this case will be 2 raised to the power n minus. Please. So there are different cases, and that's what makes the concept of onto function interesting. The first case is when mod A equals to mod B equals to n, then the number of onto functions will be exactly same as number of one function, and it's easy to calculate number of one function. They are nothing but n factorial. Yeah. Now, if mod A equals to any value which is more than 2 or equals to 2 and mod B equals to 2, then the number of onto functions possible from set A to set B will be 2 raised power n minus 2. How did we calculate this? Total number of functions minus the functions which are not onto. So this is case 2. Now let's talk about case 3. So what is case 3? Let mod A, or let mod A is equals to nothing but, yes, mod A is n plus 1 and mod B equals to n. So what actually size of domain equals to 1 plus size of domain. So this is the third case when the size of domain is exactly 1 more than the size of codomain. Size of domain we are considering from A to B. So A is having one element more than the number of elements in set B. So when size of domain is 1 more than the size of codomain, so if mod A equals to n plus 1 and mod B equals to n, then number of onto functions possible from set A to set B will be equals to what? Any answer for this question? Any answer for this question? Okay, now to understand this concept, let me give you an example and you guys try with that particular example to formulate the formula. Let's assume let mod A is equals to 4 and mod B equals to. This is the same case. The size of domain is 1 more than the size of codomain. So mod A equals to 4 and mod B equals to 3. Then how many onto functions are possible from A to B? You are not able to write the equation, then you can give me the answer for what will be the answer for this question. This is the exact same case when the size of domain is 1 more than the size of. What will be, how many onto functions are possible? We are going to derive the formula. Question. Please think or I solve. Any answer? No. Come on. Let's try to understand concept. Sir, we know that if we want to create an onto function from set A to set B, the number of elements in the domain are exactly 1 more than the number of elements in codomain, then we know exactly 2 element of the domain will map with the same element of the codomain. Exactly 2 element of the domain will map with same element of codomain, and remaining elements of domain will map with the different elements of the codomain. Yes or no? Not 27, I know. No. Please, do you realize that if cardinality of set A is exactly 1 more than the cardinality of set B, then we know that this will be the scenario that exactly 2 element of set A will map with the same element of the codomain, and apart from that the remaining element of the domain will map with the different elements of the codomain. With the different elements of the codomain, because we need to cover all these n elements using n plus 1 elements, Now the simple concept is that, sir, we have 4 elements in the domain. We have 4 elements in the domain, and out of those 4 elements we can choose 2 elements in foresee 2 different ways. So either AB can map with the same element, or AC can map with the same element, or AD can map with the same element, or BC can map with the same element, or B and D can map with the same element, or C and D can map with the same element. So out of 4 elements we can choose 2 elements in foresee 2 ways, and those 2 elements can map with one element in only one way. Now please try to understand it differently. That let's assume that we have selected 2 elements out of 4 elements in foresee 2 ways, and we have clubbed those 2 elements in a single element, because we know that they will behave similarly in an onto function, that both of them will map with the same element of the codomain. Now the idea is that if we consider these 2 elements as a single element, then how many elements are there in set A? If we consider these 2 elements as a single element, then how many elements are there in the domain? Sir, 3 elements are there in the domain. How many elements are there in the codomain? Sir, 3 elements are there in the codomain. Now the idea is then that once we have clubbed these 2 elements in a single element, once we have clubbed these 2 elements in a single element, then the number of elements in set A will be exactly same as number of elements in set B, and the number of elements in set A will be equals to equals to 3. Clear? So now the concept is, if we have clubbed this 2 in a single element, then there are 3 elements in set A and 3 elements in set B. How many onto functions are possible? Sir, 3 factorial onto functions are possible. Make sense? Make sense? Got the idea? How many of you are not able to follow this? I am just saying that, sir, if the cardinality of set A is 4 and cardinality of set B is 3, then we know exactly 2 elements of the domain will map with the same element of the codomain. Now those 2 elements can be chosen in foresee 2 different ways. Once we have chosen those 2 elements, we know that those 2 will map with the same element of the codomain. So ultimately, effectively, we need to map 3 elements from set A to 3 different elements of set B, such that every function from A to B is onto. Now, if both of them are having 3 elements, then there will be 3 factorial different onto functions possible. 3 factorial different onto functions are possible. So this will be nothing but 4c2 into factorial. So the answer will be, so this is 4c2 is 6, 3 factorial is 6, final answer will be 36. Clear? Okay, now let us generalize this for any value of mod A and mod B, such that mod A is 1 more than the size of mod B. So what's the scenario? Sir, if the cardinality of set A is n plus 1 and cardinality of set B is n, then we know that exactly 2 out of this n plus 1 element will map with the same element of set B. So out of this n plus 1 elements, in how many ways we can choose 2 elements? Sir, out of n plus 1 elements, we can choose 2 elements in n plus 1 C2 ways, and if we have combined those 2 elements, then effectively in set A there will be n elements and there are already n elements in set B. So the number of onto functions possible from A to B when the cardinality of mod A and mod B is considered as n will be n factorial, but those 2 elements can be chosen in n plus 1 C2 ways. Clear? Are you able to absorb this concept? Fast. So I know generally people think that concept of onto function is damn easy, but no, concept of one function is easy. Concept of one function is easy. Concept of onto function is quite tricky. When these are the 3 special cases when mod A equals to mod B equals to n, the number of onto functions n factorial. When the size of codomain is restricted to 2, the number of onto functions will be 2 raised power n minus 2. If size of domain is exactly 1 more than the size of codomain, then the concept which we can use, right? But in a general case, let mod A equals to M and mod B equals to N such that M is greater than or equals to N. Otherwise, onto function is not possible. Otherwise, onto function, let mod A equals to M, mod B equals to N such that M equals to N. Then generalized formula is very difficult. Then number of onto functions possible from set A to set B is equal to, sir, this formula will be, I'm not going to give you the explanation of that formula because it will take at least 45 minutes. But, and another thing, that why are you not explaining? Because a gate is never going to ask a question based on this particular formula. Reason is quite simple. What is the reason? Reason is quite simple, that they don't want you to mug the formula. Apart from that, this formula, the derivation of this formula will take at least, while sitting in the examination, both of them are not the uh, things which are judged by the gate paper. So simple concept is, they are not going to ask the question randomly. If they ask a question related to number of onto functions, then the question will be of the type in which either mod A equals to mod B, or the cardinality of set B is exactly 2, or the cardinality of domain is 1 more than the cardinality of codomain. Apart from that, for a random value of M and N, the number of onto functions possible will be n raised to the power M. Sir, what is this? So these are the total number of functions possible minus nc1 into n minus 1 raised to the power M plus nc1 to n minus 2 raised to the power M minus nc3 into n minus 1 raised to the power M. So this will keep going until, so the last time I don't know, sir, it will eventually depend on the value of n minus 1. So minus 1 raised to the power n minus 1 into n minus 1 into 1 raised to the power M. So how this 1 appears? So this 1 is actually nothing but n minus 1. What will be the value of n minus n? Value of n minus 1 will be nothing but 1. So this will be the formula. So you can also before this n raised power m, you can actually think of this n raised power m as, you can think of this n raised power n m as nc0 into n minus 0 raised power m, because nc0 will be 1. So 1 into n raised power m will be same as n raised power m. Okay. Now you can also, now the tricky part is, so this is going from 0 to n minus 1. So you can write it in the form of a series, that summation I varies from 0 to n minus 1. But in the summation, what will be the sign of the term? Sir, if this is 0, then it will be even, 1 then, 0, then it will be plus, 1, then it will be minus, sorry, 2. NC1, NC2, NC3 up to NCn minus n. So if it is 0, then term will be positive. 1, then the term will be negative. 2, then term will be positive. Then term will be negative. That's what I said. That if n minus 1 is negative, then minus 1 raised power odd term will become minus. If n minus 1 is even, then minus 1 raised power even will become plus. That's the idea. Minus of summation I varying from 0 to n minus 1. The sign of the term will be minus of 1 raised power I. Is 0, it will be positive. It is 1, it will be negative. It is 2, be positive, etc. Into nci into n minus I raised to power m. I don't think that need to mug this formula as well. Now, please let me give you an intuition. If at all you want to derive this formula, if at all you want to derive this formula, sir, what is the concept? Sir, total number of functions possible from A to B, total number of functions possible from A to B, then we will eventually try to subtract the functions in which exactly one element of the codomain is not mapped, exactly two elements of the codomain are not mapped, exactly three elements of the codomain are not mapped. So maximum elements which are not mapped by any element of the domain can be n minus 1, because it is not possible that none of the element of codomain is mapped by any element of domain, otherwise it will not become a function. Otherwise it will not become a function. So you can leave up to n minus 1 element from the codomain. You cannot leave all n elements of the codomain, otherwise it will not be a function. Otherwise it will not be a function. So the idea is, but what happens, sir? You can see plus minus plus minus plus minus, it is actually the concept of inclusion and exclusion. So we have added total number of functions. We tried to subtract the functions in which at least one element is not mapped. So when we were subtracting the functions in which at least one element is not mapped, we have subtracted the functions in which exactly two elements are not mapped twice. Therefore, we tried to add those functions in which exactly two elements are not mapped by any element. Now what happened? Sir, when we were subtracting the functions in which exactly one element is not mapped, we have subtracted the functions in which exactly three elements are not mapped three times. Now, when we were trying to add the functions in which exactly two elements of the codomain are not mapped, then we have added those functions in which exactly three elements are not mapped by any element of the domain three times. So three times subtracted, three times added. So we had to subtract it at least once. So we kept doing it, and this is what we got. And this is what we got. So this is nothing but principle of inclusion exclusion. This is nothing but principle of inclusion exclusion. But anyway, if you can remember the formula, it's okay. Otherwise, if you cannot remember the formula, then also it is okay. I don't think that any question is going to be asked on that particular formula. But please don't forget previous three cases. Case 1, mod A equals to mod B equals to n. Simple case, number of onto function will be same as number of 1 function, that is n factorial. Second case, the cardinality of set B is exactly 2. Third case, when the cardinality of domain is 1 more than the cardinality of codomain. So questions may be asked from these three concepts or these three cases. Questions may be asked from these three cases. Very rare that a question will be asked from this fourth case. Anyway, I have explained the concept. Now let's move to the bijective function. What exactly is a bijective function? Concept. A function which is both 1 as well as onto 1, that is injective, as well as onto is called a bijective function. Function both 1 as well as onto called a bijective function. That A. Now my question is, if we have less number of elements in set A, can it be if we have less number of elements in set A? Anyway, if we have more number of elements in set B and less number of elements if we have more number of elements in set A and less number of elements in set B, is it possible to have a function which is 1 as well as onto? Let's try doing this. So let's assume that we connected this. So this is onto, but the moment I make it a function, that is the moment I try to join or map this C with either 1 or 2, it does not remain 1. It does not remain 1. Now, if the number of elements in set B are more, if the number of elements to this, if the number of elements set B are more than the number of elements in the domain, if I try to keep the function as 1, let's assume I did this. Now, is it possible to make this function onto? No, sir. If I try to make this function onto, then at least one element of domain will have more than one image and it will not remain a function. It will not remain a function. Therefore, the idea is that for a function to be 1 1 as well as onto, for a function to be 1 1 as well as onto, cardinality of set A must be equals to cardinality of set B. So it is quite evident from the case that function from A to B is 1 1 can be 1 1 only if cardinality of set A less than or equals to cardinality of. Yeah. Now, second function. So this is your equation 1. Function from A onto only if mod A greater than mod B. Your case 1. If function from A is both 1 1 as well as onto. Both 1 1 onto. Then, sir, for 1 1 this condition should satisfy. For onto this condition should satisfy. For 1 1 as well as onto, both of them should satisfy simultaneously. Both of them should satisfy simultaneously. Therefore, mod A has to be equal to mod B. So a bijective function is possible from set A to set B only if both these sets have same cardinality. Yeah, so that's okay. Let's define all the things. What is it? A function f from A to B is called a bijection if function is both 1 1 as well as onto. Apart from that, bijective functions are also known as, yeah, this is another term. Bijective functions are also known as 1 1 correspondence. Please, I'm not saying 1 1 function. I'm saying the bijective functions are said to have 1 to 1 correspondence. The bijective functions are said to have 1 to 1 correspondence or 1 1 correspondence, right? So if somebody is saying that there's a function from A to B which is having 1 1 correspondence, then don't say that function is 1 1. That function is actually bijective. 1 1 correspondence and 1 1 function are two different things. 1 1 correspondence means every element of set A will have one image in set B, and every element of set B will have one image in set A, will have one pre-image in set A. So that's the idea, that 1 to 1, that from A to B as well as from B to 1, B to A, 1 A to B as well as from B to A, it is having 1 1. So it is said to have 1 to 1 correspondence or 1 1 correspondence. So if somebody says 1 1 correspondence, don't think of 1 1 function. It is actually a bijective function. It is actually a bijective function. If somebody says 1 1 function, then don't say 1 1 correspondence. 1 1 correspondence. So please note down. 1 1 correspondence is not same as 1 1 function. Not same as 1 1 function. So please try to understand what do you mean when we say 1 1 correspondence. Every element of set A will have exactly one image in set B, and every element of set B will have exactly one pre-image in set A. Every element of set A will have exactly one image in set B, and every element of set B will have exactly one pre-image in set A. Therefore, it is 1 1 correspondence, but not 1 1 function. Okay, so when exactly a bijective function is possible from set A to B? So if A and B are finite sets, then bijection from A to B is possible if and only if bijection from A to B, no, not if and only if, bijection from A to B is possible only if bijection from A to B is possible only if mod A equals to mod B. That is, if the function from A to B is bijection, then mod A equals to mod B. But if mod A equals to mod B, then it is not necessary that the function is bijection. Yes, sir. It is not necessary. Let's take an example. Mod A equals to mod B. Okay. 1. So, it may be the case that mod A equals to mod B, but still the function is not a bijection. So, mod A equals to mod B, but function is not bijection. Not if and only if. Clear? So if function is bijection, mod A equals to mod B. If function is bijection, mod A will be equals to mod B. But if mod A equals to mod B, then it is not necessary that function will be bijection. So mod A equals to mod B is a necessary condition for a bijection to exist, but not sufficient. Yeah, chalo, that's okay. Now, sir, if mod A equals to mod B, then how many bijections will be possible? So number of bijections will be same as the number of functions which are 1, 1 and onto. So every 1, 1 function will be onto, every onto function will be 1, 1. Therefore, if mod A equals to mod B, then number of bijections from A to B will be exactly same as number of 1, 1 and number of onto functions from A to B. That is n factorial. It will be exactly same as number of 1, 1 and onto functions from A to B, that is n factorial, because if mod A equals to mod B, then both of them are same or satisfy the bijective function. Yes. Okay. Done. Last concept of an inverse function. Last concept is of inverse function. So please, inverse of a function f, or let's assume let f is a function from A to B. Let f the function from inverse of function f exist. This is if and only if. Inverse of function f exists if and only if inverse of function f exists if and only if function f is a bijective function. Function f is a bijective function from A to B. So what does it mean if and only if? If function is bijective function, then inverse will exist for that function. If inverse exists for the function, then it is guaranteed that it was a bijection. Clear? Now, please try to understand that what happens. So let's assume that I have a bijection. One is a bijection from two find as it relates to one. It relates to one and so this one, yes sir. This onto, yes sir. So bijection. So the idea is if your function is 1, 1 and onto, then the inverse relation, every function is a relation, then inverse relation will also satisfy the definition of function. So here A relates with 3, B relates with 1, C relates with 2. What will happen in the inverse function? So inverse function will be defined if f is a function from A to B. Note down, if f is a function from A to B, f is a function from A to B, then inverse function will be defined an inverse function if exist, first of all, we define from the, that is, in the inverse function, domain of the function will be set B and codomain of the function will be set A. So domain will become 1, 2, 3, codomain become ABC. Now, come on, sir. From here, what do we know? Sir, we know that f of a, that is, if we pass element a in function f, then it will return 3. F of a equals to 3. So what will be f of b? Sir, f of b actually equals to 1. What is f of c? Sir, f of c will be equals to 2. Now, sir, if this is the case, then please try to understand that what happens here. Sir, the function a relates with 3. Therefore, in the inverse function, relate with the function f, b relates with 1. Therefore, in the inverse function, 1 will relate with b. The function f, c relates with 2. Therefore, in the inverse function, will relate with c. So, you will realize one thing, that is, with respect to inverse function, if I pass 1 on, if I pass 1 the inverse function, if I pass 1 in the inverse function, if I pass 1 in the inverse function, I'll get b. If I pass 2 in the inverse function, I'll get c. If I pass 3 in the inverse function, I'll get a. So do you realize that from here, f inverse of 3 will be equals to a. From here, f inverse of 1 will be equals to, from here, f inverse of 2 will be equals to c. And that's what we got. That's what we got using the inverse function also. Please try to understand, sir, why this formation is important to understand in this particular form. Because if you know this format, you will be able to calculate the inverse of a function. You will be able to calculate the inverse of a function. So what do you mean? Look at this. Let fx equals to 2x plus 3 is a function, is a bijective function. Then obtain, then what will be the inverse function f inverse x. What will be the inverse function f inverse x? Sir, there is a simple concept to obtain the inverse function. A simple concept to obtain the simple function. What is this? So let's assume that y equals to fx. Whatever value is produced by function fx is nothing but y. Sir, we know fx is nothing but 2x plus 3. No, y equals to fx. So, if, look at this, sir, if 3 equals to fa, if 3 equals to fa, then f inverse of 3 will be a. If 3 equals to fa, then f inverse of 3 will be equals to a. So, on the same line, if y equals to fx, y equals to fx, therefore, f inverse of y will be equals to x. F inverse of y will be equals to x. Yes, sir. Y equals to fx. Therefore, f inverse of y will be equals to x. Now, the idea is, now, it is a function of y. F inverse of y is a function of y. Therefore, we must represent x in terms of y. Because if you have fx, if it is a function of x, so the variable in the equation must be x. If it is a function of y, then the variable in the equation must be y. It cannot be x. Variable in the equation must be y. It cannot be x. Now the idea is, sir, from here, what do we know? Sir, y equals to fx, which is 2x plus 3. We need to represent x in terms of y. We know y equals to fx equals to 2x plus 3. Therefore, y equals to plus 3. Hence, x equals to nothing but y minus 3 by 2. X equals to nothing but y minus 3 by 2. So, we can replace x in terms of y and it will become f inverse of y will be nothing but y minus 3 by 2. So this is the inverse function. Now, sir, but it is f inverse of y. They were asking for f inverse of x. Come on, x and y are just the variable. X and y are just the variables. We can change the variable with any name. If you want, you can keep your name itself. So f inverse of x, but x minus 3. Here, what will be the inverse function? The inverse function of x will be nothing but x minus 3 by 2. So the simple concept. So how do we obtain the inverse function? Sir, if y equals to fx, then f inverse of y will be equals to x. You just need to replace x in the terms of y because f inverse of y is a function of y. Therefore, you need to represent x in terms of y. Once you have represented x in terms of y, you just need to replace both the y's in the LHS as well as in the RHS by x and you will get the inverse function in form of x. You will get the inverse function form of x. So it's very simple concept, but the simple idea is when exactly the inverse function of a given function will exist. Inverse function will exist for a given function if and only if your function f is a bijective function. If it is not a bijective function, then inverse function will not exist. Come on, why? Because if the function is not a bijection, then the inverse relation will not be a function. If function is not a bijection, then inverse relation will not be a function. Will not be a function. Need an example for that? Come on. So, if function is not 1, 1, then what will happen? So let's assume that this is a function from a to b, not 1, 1. A, b, 1, not 1, 1. This is not a function. This is not a 1, 1 function. Not 1, 1. What will be inverse? So in the inverse relation, you will have 1, 2. You will have a, b, c. What will be the mapping? The mapping will 1 will relate with b and 2 will relate with a and c. So there are two images, not a function. So if f is not 1, 1, if f is not 1, 1, then the inverse relation with respect to f is not a function. If f is not 1, 1, if f is not 1, 1, then the inverse relation will not be a function. Similarly, if f is not onto, what will happen? So this is 1, 1 function. This is 1, 1 function, but not onto. So 1 will relate with b, 2 will relate with a. No image for 3. Therefore, not a function. Why it is necessary for function to be bijective for inverse function to exist? Because if function is not 1, 1, inverse relation is not a function. If function is not onto, inverse relation is not a function. So for inverse relation to be a function, function must be both 1, 1 as well as onto, then only the inverse relation will be a function and we will say that it is an inverse function, and we'll say it is an inverse function because it is not a function. What's the point of calling it a function? What's the point of calling it a function? Clear? So that will be all. for this particular session, we have understood the concept of one function and how many one functions are possible. What do we mean by onto function, and 4 different cases to evaluate the number of onto functions from set A to set B. Bijective function, how many bijective functions? Sir, bijection is possible only if both the sets are having same cardinality, and the number of bijective functions will be n factorial, where n is the cardinality of these sets. Now, inverse of a function will exist and only if function f is a bijection. Clear? So, and we have also understood how to calculate the inverse function. So, this is the same concept. You can apply this concept in every case, no exception. Apply this concept in every case, there will be no exception for this. Thank you very much for joining the session. So, we have understood the concept of functions as well. From Monday, we'll start the concept of group theory. Clear? So again, cyclic group, subgroup are very important concept from the GATE point of view. Last 5 years, 3 times they have asked a question from group theory. So last year they did not ask, therefore they may this year they did not ask, so this year they may again ask a question from group theory. So please make sure that you understand the concept of group theory properly, especially the concept of subgroup, the concept of cyclic group, and the order of elements of the group and the relation between the order of the subgroup and order of the group. That is the Lagrange's theorem. So that will be most important in the group theory, but we'll cover each and everything in the upcoming session. Thank you very much. See you in the next session. Till then, take care, keep learning. Have a nice day.